Thus, I will discuss about the flyback converter. So, in my last class already I have discussed about the isolated converter. Therefore, the flyback converter is nothing but it is an isolated converter. Okay. Then first you should know why it is named as flyback converter. Okay. Why it is named as flyback converter. The name is came from analog TV circuit, right? The name is came from analog TV circuit. The flyback circuit. What happens in case of analog TV circuit, or what is the function of flyback converter in analog TV circuit? The flyback circuit responsible for moving a beam of light and immediately bring back to its original position. Okay. So, what is the function of flyback converter in TV circuit? It moving. It used to move a beam of light, and immediately it bring back the beam of light to the original position. Therefore, it is called a flyback. Okay. So, from that, it is named as flyback converter. But now we'll understand what is the flyback converter. So, the flyback converter is nothing but it is an isolated converter. It means the source and load is isolated by a transformer. That is, the source and load is isolated electrically, but they are coupled magnetically by the help of a high frequency transformer. Okay, here we are using a high frequency transformer that is made by ferrite core. Okay, the short question in your in most of the competitive exam, the short question is coming: which type of transformer is used for high frequency application? That is either silicon core or high grade alloy steel core or ferrite core. So ferrite core transformer is used for high frequency application. Okay, here we have taken a high frequency transformer to increase the power density. Okay, to increase the power density, because generally the flyback converter used for low and medium power supply in industry. Okay, it is used for low and medium power supply in industry, and it is very popular due to low cost. Okay, it is very popular due to low cost, and generally it is derived from buck boost converter, that is your DC converter. But flyback converter can convert AC to DC and also from DC to DC. It means this can be applicable for AC to DC converter, and also it is useful for DC to DC converter, right? And this is used for low and medium power supply. Okay, it is used for low and medium power supply. Okay, so let us now discuss about the operation and its construction. So see the circuit diagram. So this is a ferrite core transformer. Okay. And this is your switch, that is, this is nothing but a MOSFET switch. Okay, that that is your IGBT or SCR switch. Okay, so this is the primary winding of the transformer. This is the primary winding of the transformer, and this is the secondary winding of the transformer, and this is your diode. Okay, this is your flywheel diode, and this is a capacitor, right? And this is your load circuit, and this is your input voltage, and this is your output voltage. Okay, this is diode D. Okay, and this is denoted by dot, that is current. It means the current enters here, and this is the secondary side dot. It means current enters here. Okay. So generally it consists of a what? Generally it consists of a thyristor switch, that is your IGBT or SCR. Okay. This is your source voltage or input voltage. Okay. And this is the primary winding of the transformer, and this is the secondary winding. So let us assume that this is your primary winding NP and secondary winding turns NS. Okay, and this is nothing but a switch. This is a switch. Okay, so practically what happens, this is the main component of a flyback converter. This transformer here, what is the function of this transformer? The main function of transformer, it isolate the input and output. Okay, it separate input and output electrically, right? Transformer separate input and output, that is source and load. Okay, um, it separates or isolates source and load. The second function of the transformer, to store electrical energy. Okay, here transformer is also used to store electrical energy. Here this primary winding act as an inductor. This is also act as an inductor. Okay. So what is the function of inductor? Inductor is nothing but a storing element. Capacitor also a storing element that stores electrical energy. Okay, that stores electrical energy. But what is the function of a resistor? That dissipates electrical energy. The resistor cannot store electrical energy, but it consumes electrical energy or dissipate electrical energy. So here induct, the main function of the transformer, that is it stores electrical energy and isolates the source from the load. Isolates, this is the source and load. What is the advantage of isolation? In case of buck boost converter, what is there is no isolation. It means the source and load are not isolated in a buck boost converter. That is the main disadvantage. Therefore, we cannot. That is the buck boost converter is used limitedly. Okay, but as this converter is having isolation facility, therefore it can be used vastly for low and medium power supply. Okay, so that the operator in this side, okay, the operator and equipment connected to the source, okay, the operator and equipment connected to the source is 100% safe. Okay, then now we'll understand how it works. Now we'll understand how it works. First, we'll discuss about the basic operation. Okay, first we'll discuss the basic operation of this circuit. What is the basic operation? Basic operation. Listen here. Let us assume that, okay, here the switch is T1 is on. Okay, when the switch is in the on condition, okay, let us assume that the switch is in the on condition. Then what happens? This side will be plus and this side will be minus. Okay, and this side will be plus and this side will be minus. Clear? When the switch is in the on condition, it means when T1 is on, then what happens? This forms a closed circuit. The current flows like this. Okay? The current flows like this because this forms a, the switch acts as a short here. Okay, it acts as a short circuit, right? When T1 is on, it means the voltage across this switch is equal to 0, right? The voltage across this switch is equal to 0 because it acts as a perfectly short circuit. Okay, so then what happens when T1 is on? The current starts flowing due to this input voltage. Then the what is the function of inductor? The in during this period, inductor stores electrical energy. Okay, during this period, the inductor stores electrical energy. But secondary side, what happens? This side is plus and this side is in minus. Therefore, the negative is connected to anode of the diode. Therefore, anode act as an what? Open circuit. Sorry, the diode act as an open circuit. Okay. Therefore, no current flows in the load. Okay, no current flows in the load side. Okay, zero current flows in the load side. So then after that, after some time, okay, the T1 is off. When T1 is off, clear? When T1 is off means this act as open circuit. This act as an open circuit. Then what happens when T1 is off? Okay, when T1 is off, this stored energy, okay, move to that is secondary side. Okay, and this side will be plus, this side will be minus, and this side will be minus, this side will be plus. This will be natural naturally this plus minus, when the switch is off, the polarity of this changes. This is plus minus. Okay, this will be plus, this will be minus, and this side will be plus, this side will be minus. Then what happens? The diode is in the forward bias. The diode is forward bias. When the diode is forward bias, the current starts flowing and the capacitor is charged. Okay, the capacitor is charged. Clear? So after some time, when it will be in the on, okay, when this switch again will be in the on condition, right, when the switch is in the on condition, again this side will be plus and this side will be minus, and this side will be minus and this side will be plus, so that the diode is in the off condition. When diode is in the off condition, what happens? No current will flow. Therefore, capacitor starts discharging through the load. So in that time we'll get a load current. Okay, and this is in cyclic manner. The switch is in the off and on. Okay, this cycle is repeated. Okay, so this is the basic operation of a flyback converter. Next we'll discuss about the detail operation of detail operation of flyback converter, right? Detail operation of the flyback converter. So listen here. So generally there are two modes of operation of the flyback converter. One is when the switch is in the on condition, that is called a continuous mode of operation. Okay, that is called a continuous mode of operation of the flyback converter. And when the switch is in the off condition, that is called a discontinuous mode of operation. There are two modes of operation. That is mode 1. Listen here. The mode 1, when T1 is equal to on, that is switch is in the on condition. Then what happens when T1 is in the on condition? So just you draw that circuit diagram. You can quickly draw that circuit diagram. So this is your P in, or you can write also source voltage, and this is your secondary, this is NP, and this is your NS. Okay, and this is your capacitor. This is your load resistance, right? So this side will be when T1, sorry, let us connect one. This is your T1, okay, this is your T1, clear? So So when T1 is in the on condition, okay, what happens? The energy stored in this, okay, the energy stored in the primary winding, in that time what happens? This side will be, that is your diode is in the off condition. The diode is in the off condition. When diode is in the off condition, what happens? Capacitor, okay, ପୂର୍ବରୁ capacitor ରେ ଯୋଉ energy store ହେଇଥିବ ସେଇଟା କଣ ହବ ନା it will flow to the load. Okay, it will flow to the load or it will discharge to the load circuit. Okay, the stored energy in the capacitor will discharge when it will be in the on condition. Okay, so energy stored in the primary winding, right, when switch is sorry, this called continuous mode of operation. This is called continuous mode of operation, and during this period energy stored in the primary winding uh, and charge already stored in the capacitor C discharged to the load as the diode is in the reverse bias condition. Okay, as the diode is in the reverse bias condition. This is called continuous mode of operation. So thank you very much. Today I will end the class here due to some problem. Okay. So today I will end the class here.